My name is Grant Fritchey. Welcome to my session. Today we're going to be talking about containers, Azure DevOps, and Flyway, and why this is the perfect combination to automate your database deployments. Now, before we get started, just let me introduce myself. My name is Grant Fritchey. I work for Redgate Software. I'm the product advocate there, and this is my contact information. If you want to get in touch with me after today with questions on DevOps, Flyway, database deployments, this kind of automation, please do. I am a Microsoft MVP, and I am an Amazon community builder, so I do a lot of this kind of stuff, and I'm happy to answer questions anytime. Now, if we're talking DevOps, let's just kind of level set and talk about what it is that we're talking about. DevOps is an agile culture, and that agile culture is all about supporting people, and it has to foster communication, and it has to foster teamwork, and it has to foster, this whole idea of a shared burden. It's actually all about collaboration and communication, but it's driven by process. And once we've defined the process, we can then begin to automate. And that's the key. Support the people in order to define a process, define the process in order to automate the whole thing, and then we can get going and actually get speedy deployments done. Only there is a little bit of a problem. Databases. Now, databases have always been a challenge. Just from the get-go, databases are harder to automate. And there's a number of reasons for this. It's not any one reason. There is a whole slew of issues. Now, the first one is data persistence. Now, if we could just drop or replace a database the same way we replace code, the way we replace an executable or a DLL or a container, we could just throw one away and put a new one in its place, database deployments would be easy. But we have to keep the data. Data persistence is a fundamental issue for database deployments. So we have to write our code and our scripts to take into account the fact that the data must persist. Now, the next problem you're going to run into with databases is database size. Frankly, the size of a database becomes extremely difficult to deal with. There is so much there, so many different things that you're going to run into, so many different ways that database size can affect what's going on with your deployments. So you need to take that into account when you write your code. And that's something that just, once again, makes databases more difficult. Also, let's talk about the code. Now, a lot of us are familiar with SQL, PL SQL, T-SQL, PostgreSQL, MySQL. We've got that experience. Maybe you just know ANSI SQL, and that's great. But the code entailed in data modification, in changing structures, is frequently unique to the operating system and to the relational database management system that we're talking about. So a create table statement for Postgres, for example, is very similar to one for SQL Server, but they're not the same. And in fact, there's a lot of differences in the way that behaves. So our deployment automation becomes much more a question of how much knowledge do we have and how much things can we get done. Also, databases cause us to go through compliance. Compliance regulations are a huge deal in our modern IT infrastructure. We have to take that into account as we go. And data is just the main thing. It is the one place where we've got more security, more protections. And the beautiful thing is DevOps, a good DevOps process, supports protection. A good DevOps process helps us better protect our databases. But again, it makes the deployments more difficult. We have to take that all into account. And maybe we have to run scripts, in a repeated fashion over and over again at the beginning of a process. We just don't know. So there's so much involved here with the regulations and databases. And then finally, frankly, it's the differences in tool sets. Writing code for Oracle through PL SQL is very different than writing code for MySQL. They just are. And the tools that support us vary wildly from one environment to the next to the next. So how do we go about meeting these challenges? Well, the first is, frankly, we need to standardize our deployments the same way we standardize our application deployments. And so today I'm going to give an example of one flow control mechanism, Azure DevOps. And I'm going to show a continuous integration process using Azure DevOps just the same way as you would do a continuous integration process using your own code. But in this case, I'm going to do it with databases. Now I'm also going to bring in another tool. The other tool I'm going to bring in is containers. Why containers? Well, again, databases being such as they are entails we have to do installs, we have to do setups, we have to create databases, and a lot of that can be difficult, time consuming. Do we have to maintain a virtual machine over time? What can we do to virtualize our data management system but still have databases to test our code deployments against? Well, that's where Docker containers come in. I'm going to take advantage of Docker containers and the fact that I can create on the fly a Postgres Docker container and have a Postgres database available to me. I'll show you how we do that. It's not that hard. There are little bits and gotchas that you kind of have to think through, and we'll talk about a whole bunch of those. But the basic idea is really simple. We create a container. On that container, we create a database, and then we can do our database deployments. Now that's the last step, is how do we do our database deployments? And this gets complex, but that's why we're bringing in another tool. The other tool we're bringing in is Flyway. Now Flyway is an open source tool, fully available. Download it right now. You can go to flywaydb.org and get a copy of it for yourself to experiment. I'll show you how it works today, and then you can go and get a copy of it and play with it tomorrow. No problem at all. It's great. It works. It's fine. So no cost, no licensing cost. You can get your own copy of Flyway. And the beautiful thing about Flyway is it's actually database agnostic. Now in this case, I am posting Postgres. I am using Postgres to do my deployment, but I could be doing Microsoft SQL Server. I could be doing Azure SQL Database. I could be doing AWS RDS. Oh my gosh, the list is long. I mean, you name the relational database system, Flyway supports it. Over 20 different databases have been validated as working with Flyway at this point in time, and more are coming, and there's others that we just haven't tested yet. So we're sure it works, but you may have to test it yourself on some of the more obscure relational database management systems. But all the major ones are supported, and a whole lot of minor ones are as well. So you can really get in there and start using it. And then the other beauty of Flyway, one of the things that just makes it so much fun to use, is that it's all down to your code. You get to define the way the code works. So you're not limited to working one way. You've got to build things out through YAML, or you've got to plug things in through XML. Nope. You like to use Postgres. I like to use Postgres. Fine. Let's write our SQL using Postgres SQL, and then we can run deployments on it. So, enough of me blathering. Let's go look at some demos. Now I want to start off here. Now I'm in Visual Studio Code because I'm going to be using I'm using Azure DevOps, and I want to be able to hook up to it easily. So Visual Studio Code works really well for that. Now what I've got is a really simple example today. We're going to create a new table for my Ham Shack Radio database. And for my Ham Shack Radio database, we want to add a table called GMRS. Cool, great, easy enough. What we're going to do is save this file. So Control Save. Now, what we're seeing here is the beginning of Flyway and the way Flyway works. Now let's back up just a little bit. Now what we've got is I've got a main SQL statement that I use for creating databases, but it's not part of the code. Instead, I've got everything collected into this folder, this large scale, uppercase SQL folder. And then in here, we have got all of the scripts for deploying databases. Now, Flyway uses a naming standard. It's pretty simple and pretty straightforward. Let's go ahead and name this new script that we need to run per the Flyway naming standard. So we'll call it v7.2 underscore underscore creating GMRS table. So that's it. What it is the naming standard is a capital V and then a number. Now the number can be any one you want. I've been using 1, 2, 3, 4. You could do other ways as well, but you just have to have it be a number that you can put in a correct order, and then Flyway just picks up the order and runs the scripts as needed. So the fact that you've got version v7 and then v7.1 and now v7.2, v7.2 will be run after the other scripts are run. So we'll go ahead and hit save, and that's going to add it locally to my file system. Now you'll notice over here on the left, we can see that there's been a change noted in my source control because I've added another file to the folder. Okay, well, let's go ahead and stage that change. So now the change, we know the change is going to work. We've already tested it locally. We know it's going to work. So let's go ahead and check it in. Adding new GMRS table. So I'm going to commit this locally to my Git repository. I'm running Git locally, so I've got versions locally, and as I'm working on my code, I can protect it locally through source control. Awesome. Once I'm done with that, I'm going to go ahead and do a push in this case. We're not going to go through the branching process. Of course, you could branch and merge and all the rest of the things that you would need to do from a normal standpoint, but in this case, we're going to push. Because what I'm actually doing is moving my code from my local system up to Azure, up to GitHub actually. So I've added my code up to GitHub, and now we're going to move over to Azure. And so what I've got here is a Azure pipeline. Now that Azure pipeline is going off of a repository, and we can take a look at the files in the repository here. Let's go ahead and open it up. And if we take a look at the SQL file, you'll notice that in fact, there it is, 7.2, creating the GMRS table, has been added to the source control, and we have that code exactly as we expected to see it. Now, in the background right now, this is running. I'm not going to show it to you yet. Let's walk through what this pipeline does. Now, this is a very simple, even simplistic pipeline to simply show the concept of setting up a database, doing a deployment, successfully or not, and then tearing that database down. And it's using containers to get this job done so that things are quick and simple. So what I've done is I've got 3 PowerShell commands I'm running. The first PowerShell script creates a container called HSRCI, Ham Shack Radio, continuous integration. So it's a continuous integration database. I'm passing it in the password, the port mapping, and for some reason, I have to wait a few seconds for it to launch in order to connect up to it. But then I connect up to that local database, and I create, it's to the local Postgres instance that I've created inside of a container, and then I create a database called Ham Shack Radio. And that's it. Simple, clear, straightforward. Nothing to it. This is just creating a blank database inside of a Postgres container. Next, Flyway, a little bit of magic. Now I've got a whole bunch of different commands here. We're going to skip past them and focus in on just the one that I'm running right now. And that's right here. And it's Docker run. There we go. I want to get it in the center of the screen so you can see it. Docker run, and then I'm passing in a couple of volumes, my local repository path, SQL. If you remember, that's where my scripts are stored. Flyway, SQL, so it knows where that's at. And then I'm passing in a configuration file, and that's again in a configuration folder. That is where I keep track of all the connection strings and everything else for connecting up to my Postgres database for Flyway. Also, my Flyway licensing is there and some other stuff, but it's all things to track that. And then I'm passing in a command, migrate. That's it. Simple, straightforward. There's no real tricks here. Now, after that is done, we then Docker stop that HSRCI container and then Docker remove the HSRCI container. So this entire process will create a container, put a database inside of it, do a test deployment to validate that that works, and then tear that all down and go away. Now let's take a look at the results of what we've just done. These are our pipelines, and you'll notice it's got a green check mark. It's already succeeded. Let's go ahead and click on it. It's going to drill in, and we can take a look at the details. And so here is the process that it went through. So it initialized the job, which is normal. It's going, where is your agent? What is the agent doing? Is everything okay? What is the agent running as? You've got information all about this. Agents are where you control security through Azure DevOps. Very important that you set these up correctly. So the next thing it's doing is it's going to my repository. Now I'm using GitHub. It could be Git, TFS, SVN, whatever, but I am using GitHub. It's going in there and it's pulling the information out from Git. So it's retrieving all the changes that I've added. Next, it's running the reset command. That's the command where it creates this new HSRCI container. Then inside of that HSRCI container, it creates a database called Ham Shack Radio. So that statement was completed successfully. Next is we are running a deployment. Now the deployment ran successfully and finished. So it's all done. It worked. Your database is done. Then finally, I stopped the HSRCI and then I deployed the HSRCI. So what we've got then is, and then of course it finished the checkout process through the source control. And that was it. The entire job was done. So it's all finished up. Nice, simple, and straightforward. Clean and easy. So we've got our database deployments now. We can start to then add to it. What you would normally want to do is go back in here and edit the pipeline and begin the process of walking through here and adding additional tests, validations, all that fun stuff. Or the next step might be to load data into it. Or even you might want to take a look at another product from Redgate called Spawn. There's a free trial right now. You can try it out. That allows you to create containerized databases with data based on backups or other containers. It's a fantastic new tool, a lot of fun stuff. I'm not going to demo it today, but what it will allow you to do is add a whole bunch of additional steps in here so that you can do more testing. But the actual core of it is we are able to create this Flyway database on the fly and deploy to it very, very fast, very, very easily through this process. So this is just the question of getting Flyway set up and configured and then running through the container process to get all these things to run. There's just not a whole lot else to it. It's pretty straightforward. Let's go back to the slides. All right, so let's talk about what we did. We started off in Visual Studio Code. From Visual Studio Code, we wrote some PostgreSQL to create a new table. We validate that code, of course, we test it locally, runs on my machine, important first step. Once that's done, we then add that code to our local Git repository. So I'm versioning my code locally. And this is database code. This is full-blown database code. With my database code version locally, it's all good, it's great. Once I'm happy, I can then push the committed data code up to my central repository, in this case GitHub. And from GitHub, we then have a triggering event to run the Azure DevOps pipeline. The Azure DevOps pipeline calls to an agent. That agent's running on a Windows machine, in this case my laptop. And that Windows machine has that agent. That agent receives the command from Azure DevOps. In this case, those 3 PowerShell scripts you saw. Script number 1, create that container for Postgres. Script number 2, use that container to create a database. I'm sorry, second statement in script number 1. Script number 2, run the Flyway command, which ran successfully. Script number 3 is tear all that back down and remove it. In other words, a simple CI process facilitated by Flyway and Docker. Docker and containers are what allow us to do this all really, really simply in a small space. Flyway is the magic thing that gets our code from source control into a database. And that's what's so important, is the fact that we are able to go from our source control system to a database successfully. And all of these tools work together to support the process that our people have defined. Now, I'm live online right now answering questions. Probably as you've gone through, I've been answering questions. But you can see what's going on. And what I want to do is just say thank you for watching. Appreciate your time. I hope you're enjoying the Yugabyte conference and you're getting a lot of database stuff going on, and the summit is doing well for you. And here is some additional stuff. You can go with Slack or go to GitHub and take a look at the information available there. That's it. Thank you for watching. My name is Grant Fritchey. I work for Redgate Software.